In this simulation, I will be using 6-sided dice to represent the decay of a radioactive isotope. Each single die will represent a radioactive nuclei. Each roll of the dice will represent a unit of time. Every time a 6 is rolled, the die is considered to have decayed. Decayed dice are removed from the sample, thereby reducing the number of dice remaining. This process is repeated until the very last die has decayed. A graph of dice remaining versus the number of rolls will be constructed, from which an estimate of the half-life of the dice simulation can be made. The larger the sample size of dice, the better the model. So let's undertake a 90 dice simulation. The following graph displays the dice remaining against the number of rolls of the dice. It can be seen how it models the theoretical half-life decay graph shown. At 0 rolls, there are 90 dice remaining. It takes approximately 3 rolls to reduce the number of dice remaining to half its value, being 45. In this scenario, the half-life is approximately 3 rolls of the dice. At approximately 0.6 of a roll, there are 80 dice remaining. It takes approximately 3.6 rolls to reduce the number of dice remaining to half this value, being 40. In this scenario, the half-life is approximately 3.0 rolls of the dice. At approximately 1.2 rolls, there are 70 dice remaining. It takes approximately 4.2 rolls to reduce the number of dice remaining to half this value, being 35. In this scenario, the half-life is approximately 3.0 rolls of the dice. At approximately 1.9 rolls, there are 60 dice remaining. It takes approximately 4.8 rolls to reduce the number of dice remaining to half this value, being 30. In this scenario, the half-life is approximately 2.9 rolls of the dice. At approximately 2.7 rolls, there are 50 dice remaining. It takes approximately 5.6 rolls to reduce the number of dice remaining to half this value, being 25. In this scenario, the half-life is approximately 2.9 rolls of the dice. At approximately 3.6 rolls there are 40 dice remaining. It takes approximately 6.5 rolls to reduce the number of dice remaining to half this value, being 20. In this scenario, the half-life is approximately 2.9 rolls of the dice. Averaging the 6 half-life scenarios, the average half-life for this dice decay is approximately 2.95 rolls of the dice.